this is the last lesson of Unit 14. So in this lesson, we're going to learn some special properties about concentrated acids and also how can we deal with those concentrated acids and where are we going to use those concentrated acids. Okay, so on page 10 of your notes, it has lists out 3 kinds of concentrated acids. Okay, so we have concentrated hydrochloric acid, concentrated nitric acid, and concentrated sulfuric acid. Okay, so we are going to, first of all, let's talk about what they have in common. Okay, so for all 3 concentrated acids, they are all colorless. Okay, and the first 2, concentrated hydrochloric acid and concentrated nitric acid, they are volatile. However, you need to put a star for concentrated sulfuric acid is non-volatile. Non-volatile. Okay, so what does it mean, volatile? Volatile means it readily turn into gas in air, so you will see the white film formed as soon as you open the lid. So here I find a photo to show you. Okay, so you can see this is a concentrated hydrochloric acid. Okay, concentrated. As soon as you open the lid, you can see some white film coming out. Okay, that's showing that concentrated hydrochloric acid is volatile. So this will happen to concentrated hydrochloric acid and also concentrated nitric acid. And one thing that's special about nitric acid you need to draw down. So usually we store nitric acid inside this kind of brown bottle. Okay, there is a special reason for that, is that under sunlight, nitric acid can easily decompose. Okay, so that's why we usually store it in a brown bottle. Okay, and then let's go back to page 10. So these are some special property you need to remember. Okay, and if we take a look at the second row here, it says something called concentration. So in the next unit, we're going to learn what does this term mean, concentration. Okay, you can see a unit here, which is a capital N. We call it molar. Okay, so for concentrated hydrochloric acid, it can go up to 11 molar. Okay, so what does it mean, concentration and this unit molar? Okay, for this unit, I want you to have a brief idea. So if suppose we have a beaker of the concentrated, let's say that's a concentrated hydrochloric acid, okay, and then we have a beaker of a dilute hydrochloric acid. If both of them we have 100 ml of the solution, okay, 100 ml. For concentrated hydrochloric acid, we would have lots of hydrogen ions and a lot of chloride ions in it. Okay, but for dilute hydrochloric acid, maybe we just have a few, okay, of hydrogen ion and a few chloride ion. Okay, that's what concentration means. Concentration means in a unit volume how much substance are in there. Okay, so in the next unit you're gonna learn detail how to calculate concentration and what does the unit means. But now I just want you to have a brief idea. So for concentrated acid, that means we have got a lot of acid like H plus in the solution. Okay, so now let's go back to the table on page 10. Okay, so how do we get hydrochloric acid? We dissolve hydrogen chloride gas into water to form hydrochloric acid. Remember, water must be present in order for it to perform the acidic property. Okay, and we cannot dissolve up to 100% of hydrogen chloride gas in it. Okay, up to 35%. That's the maximum amount we can have the hydrogen chloride gas in it. Okay, hence the maximum concentration we will achieve is 11 molar. Okay, but if I take a look at concentrated nitric acid, we can dissolve up to 70%. That means we can dissolve more in a unit volume. Okay, or here we say by mass. So as you can see, the concentration hence increase because we got more high HNO3 in it. Okay, and for sulfuric acid, we can go up to 98% by mass. 98% by mass, so the concentration will increase up to 18 molar. And for the state symbol, and usually for even concentrated hydrochloric acid and nitric acid, we still write AQ. Okay, it's only sulfuric acid that we will be able to write liquid because it's we will be able to write liquid because it's up to 98%. Okay, so that's you need to remember. Then we move on to the fourth row. Okay, all of the concentrated acids they are highly corrosive. That makes when we deal with it, we must wear safety goggles and also we must wear protective gloves. And better for those volatile concentrated acid, we highly recommend that you do it in the film cupboard. Okay. And the next one, when we use concentrated acid, okay, the reaction rate, of course, it gonna increase. Why? Okay, so if we go back to the diagram I just drew. Okay, if we put a metal in it, suppose let's say put an iron into both solution. In the dilute one first. In the dilute one, okay, just a representation, we only got one hydrogen ion that will be able to react with the ion Fe. And since those ions, okay, remember in grade 7 you've learned those particles are moving all the time, so it actually takes some time for hydrogen ion to just move to the Fe particle, then they will have the reaction. Okay, but if we put the Fe into this concentrated hydrochloric acid, this Fe particle would have a higher chance of meeting one of the H plus in the solution, because there are more H plus in the concentrated hydrochloric acid, so higher chance for Fe to meet H plus, and hence it would lead to a reaction. Okay, so for the concentrated acid, it will give you a higher reaction rate. Okay, and that works for all concentrated acid. And then the last, okay, so you can highlight that part, faster rate. And then for the last row, we are going to talk about the chemical property. Okay, for concentrated hydrochloric acid, it would almost behave the same like the dilute hydrochloric acid, but it just gives you a faster rate. So you need to draw down, it will only show acidic property. For concentrated nitric acid, Of course, it will show acidic property. But it also has something special, which is called the oxidizing ability. Okay, so in grade 11, so next year we're going to have a whole chapter talking about what's oxidizing property. Okay, so I will not go into detail now. Okay, so let's discuss it next year. Okay, and then for the last one, concentrated sulfuric acid, again, it will show acidic property. And similarly to the concentrated nitric acid, it can show oxidizing property. And lastly, a very important property you need to remember for this unit is that it has dehydrating property. Okay, dehydrating property means it can absorb water, so it can take away water from other substance. Okay, but make sure you jot it down. Only concentrated sulfuric acid can do it. Okay, so the dilute one won't have the dehydrating property. So here I've attached a video. Okay, I would attach a link to online so you can watch the video. It shows the mixing of a sugar, which is the sucrose, with concentrated sulfuric acid, and it would turn the sugar into a black solid, and also the black solid gonna expand. That's because, okay, let's write the formula for sucrose, which is C12H20O11, or otherwise we can write it in this form. Okay, so when we put this sucrose with concentrated sulfuric acid, it would take away all the water. Okay, it will remove the water. Hence, it will left with only carbon. So that's the black solid left, okay, in the beaker. That's carbon. And why in the video the carbon expand? Okay, that's because this reaction is highly exothermic. That means it releases a lot of heat. Okay, so that's special about concentrated sulfuric acid. So we've mentioned for concentrated acid, they are all corrosive. So how should we deal with them? Let's move on to almost the last, page 11 of your notes. Okay, some safety precautions that we need to take when we are handling acid and alkalines. So first of all, we must wear safety goggles and also wear protective gloves. And then secondly, concentrated acid or alkaline should be placed in the fume cupboard. Okay, because concentrated, for example, concentrated hydrochloric acid and concentrated nitric acid, they are volatile, so they will release the corrosive gas. And normally, if we don't want to use a concentrated acid, and then we would take the concentrated acid and dilute it. So how do we do it? Okay, here is a diagram. Remember, we should always add acid into water. Okay, add acid into water, not the other way around. Okay, so acid must be slowly added with stirring. So there are two key words: acid, slowly added, and then with stirring. So when you answer questions, you need to have both of the criteria. And also, it should be added to the large amount of water, okay, because it's gonna generate a lot of heat, so we say it's highly exothermic. Okay, so produce a lot of heat. If we do it the other way around, because it would generate a large amount of heat, so it would instantly change the water into steam, and it causes it to splash out, causes acid to splash out, and it may get into contact with your skin, which is quite dangerous. So please don't do it the other way. Again, the proper way of doing it, I will attach the link of the video for you to check after the lesson, or you can pause it and watch the video now. Okay, let's complete the checkpoint question here. What should you do if you spill concentrated acid or alkaline onto your skin? Of course, first of all, you need to wash it immediately with running tap water. Okay, so you need to get away those concentrated acid or alkalines from your skin. Okay, and then the second question asks you, state whether the following statement is true or false. Explain your answer. When concentrated sulfuric acid is diluted, water should be added slowly to the acid. Okay, that's a false statement. We mentioned we should always add concentrated acid slowly with stirring to the large amount of water. Okay. Must be slowly added with stirring to the large amount of water. Okay, so the last thing in this unit, we're going to talk about the special property of concentrated sulfuric acid. Okay, we mentioned concentrated sulfuric acid is got dehydrating property. That means it can take away the water from other substance. So in chemistry, we call this kind of substance drying agents, and for their property we got a special term to describe it. Okay, so the first term you need to learn is hygroscopic. Okay, so for hygroscopic substance, it means it can absorb water vapor from the air. Okay, water vapor from the air. And here we got example, concentrated sulfuric acid. If we left concentrated sulfuric acid in a beaker for some time, later you will see the total volume of the solution before is at this level, but after it go up to here, okay, the total volume increase. That's because it have drawn water vapor from the air into the beaker, so the volume of the liquid increase. That shows it got this hygroscopic property. Okay, and you need to note that usually for hygroscopic substance, it will stay in the same physical state. So if it's solid, after it absorbs water, it will stay as a solid. Okay, so other hygroscopic substance, we got example like calcium oxide, and we got silica gel. But usually you can find this inside the small bags of your snacks or chips. Okay, So that's for the first one. You need to remember hygroscopic substance. And then the second type you need to remember is this. Deliquescent substance. Okay, what's special about this? Okay, deliquescent substance means it can absorb water vapor from the air, and then eventually it would dissolve and form a solution. Okay, so for example, if we have anhydrous means no water in it. Okay, if we have anhydrous sodium hydroxide, after some time it will absorb water vapor in the air and turn into a solution. Okay, so that's deliquescent. Okay, and other examples are we can list out is calcium chloride, which is a solid, and we also have potassium hydroxide. Okay, so they can all absorb water vapor in the air and form a solution. So now we got quite a large choices of drying agents, but how we're going to use it and how which one are we going to select, we're going to learn in the next page. Okay, so normally we got these three setups. Okay, the first one, if the drying agent is a solution, we can use the first one. Okay, what's special about this one is that you need to remember the length of the two delivering tube. Okay, the gas is coming in to the solution using a long delivering tube, and it's coming out using a short one. Okay, you can pause a video here and think about why it's not the other way around. Why the gas is not coming up to here, and then okay, another tube going out, okay, from the drying agent. Okay, the reason for that is when the delivering tube is sending the gas into the drying agent, which is concentrated sulfuric acid here, it makes sure all the gas would go through the drying agent and have sufficient contact with the drying agent, and then it will go out as a completely dry gas. If it's the other way around, we could have the gas coming in but with little or no contact with the drying agent and then leave the setup. So it's not efficient. So you must remember the length of the two delivering tube. And it's quite straightforward for the second and third setup. So the gas come in, going through the drying agent and then goes out. Okay, the same for the third setup. It would encounter the drying agent and then leave the setup as a dry gas. Okay, and in laboratory, and sometimes we can use this desiccator to keep our chemicals dry. Okay, so if I zoom in a little bit, you can see it got holes in here. Okay, those holes would let the air going through, and we have the drying agent at the bottom, which would absorb the water vapor inside this desiccator and make sure this our chemicals would not get into contact with the water vapor. Okay, so that's a setup that we also use in the laboratory to keep our chemicals dry. Okay, so the last question is that we need to carefully consider what's the possible drying agents that we can use. Okay, there is a principle that you must remember. The drying agent should not react with the materials being dried. Okay, what does it mean? For example, we've mentioned ammonia gas is a special case. Ammonia gas is basic. Okay, that means it will react with anything that's acidic. Okay, ammonia gas is basic. Okay, so it will react with anything that's acidic. It will have neutralization reaction. So we would not be able to use anhydrous calcium chloride or concentrated sulfuric acid. Okay, because neutralization reaction gonna happen. So what we can use is calcium oxide. Okay, so here I will help you to find out what kind of dry agent that will be suitable for what kind of gases. Only common examples will be listed here. First of all, for drying agent, okay, we can separate them as acidic drying agent and also basic drying agent. Okay, so for acidic drying agent, of course, concentrated sulfuric acid should be placed here, and also, as we have mentioned up here, okay, anhydrous calcium chloride, that's also an acidic drying agent. And for basic drying agent, of course, we have potassium hydroxide, and also calcium oxide is also basic. Okay, so now we can classify our drying agent, and then we also need to consider what are the gases we need to dry. Okay, so for some common gas, okay, acidic gas, okay, we have mentioned in our notes, when sulfur dioxide dissolves in water, okay, so if we have wet sulfur dioxide, it would turn into sulfurous acid, and also the same way for carbon dioxide, so they are acidic. For basic, you must remember the special example, which is ammonia. Okay, so now we have listed out two sets. So the principle you need to bear in mind is that we should never use any basic drying agent to dry any acidic gas. Okay, no, it should not work in this way. Basic will not be used with acidic gas, and also acidic drying agent should not react with basic gas. So the preferred combination would be basic drying agent with basic gas and acidic drying agent with acidic gas. Okay, so that's the end of Unit 14. If you have any question, you can message me or post comments in our Google Classroom.